So this is my code for the naive Bayes implementation. So in this first method here, it's just reading in the list of terms from the text file. In this method, this is for reading in the label files and the data files. So those are CSVs. So there's the train data and the test data and train labels and test labels. So this just reads them in and puts everything in a matrix. This is the function for naive Bayes, so it's mainly based on the slides from the lecture. So I declared all of these variables as they are in the slides. This holds in or saves the model that I learn in this function. For each class, we want to keep track of all of the documents that are in that class, and using that, we can firstly calculate the priors for class I. So for each document in this class, we add it to TI element-wise, so that TI essentially stores a index for the frequency of each term in this class. And then NI is the total number of terms in the class, and then using all of that, we can calculate the posteriors for each word for each term given a class, and then put that in the model at the index of the current term in the current class. And then we get our learn model. I made a list to store all of the class probabilities that we're going to calculate. For each class, which the length of the priors given from the model is the same as the number of classes, so I just did length of priors here. We have the sum of logs that we want to keep track of. So for each term, we compute the sum of logs, natural logs, for each term given each class. Next, we do the sum of log probabilities, so we combine everything and the log of the priors for this class. And then we add this sum of log probability to our array that keeps track of all the class probabilities, and then we get the max out of this class probability array, and that returns the predicted class for this sample. So now that our model is trained and stored here, we can get the priors. So earlier I store the list of priors in the last element of the model, or in the last position in the model. So if we get that and just print it out element by element, we can neatly get the class's output with their corresponding priors. And then to get the posteriors, I just have a list of example words, terms here. So we want to compute the posteriors for each class for each of these terms. So this is all just stored in the learned model, so we're essentially just indexing it for each term in this list for each class. So if we run that, we get each term and then the corresponding posteriors per class. To calculate predictions, in this case it's from 0 through 19, we just call our classify method, and then lastly, this is my method for accuracy. So essentially what this is it calculates a prediction for each element, and then it subtracts the actual label from the predicted label element by element, and then I count how many of those answers are 0, because if they're 0, then that means that they're equal, which means that the prediction was correct, and then I just divide that by the total length, or the total number of predictions. So we get our accuracy output and print it out here.